Hello guys, welcome to another Python tutorial on machine learning. In our last few tutorials, we saw different techniques in machine learning using dataset from sklearn and scikit-learn, website. So I mean, those datasets are pretty much perfect. You have all the values and everything that you want is like custom made so that you could train all sort of algorithms and classifiers in the scikit-learn library. So now what we are going to do is like, let's say you're going to in the real world, your data set is not going to be perfect. You'll be having some missing data. Sometimes you'll be having categorical data. Sometimes you'll be having data that has no meaning. It doesn't make any sense at all. So how to deal with those kind of data? So that's what we are going to discuss in next few videos. So let's get straight into it. So as I normally do, I'm not going to type any codes. I'm just going to copy paste from my uh, from my training, the code that I've used for training. To prepare myself for this YouTube tutorial. So first and foremost, we need these two, pandas and string IOs. So first I'll bring that in, and then we're going to create a comma separated data, comma separated values. So shit, I'll just copy this one. So this one, copy, paste. So it has to be in exactly same format as you're seeing right now. So what? Yeah, so we're going to convert this into a pandas data frame. So that's what we're going to do. So let's bring it furthermore. So copy this and paste. So what this is doing is like it's actually converting this data set into like a pandas data frame. So comma separated values, these are all the comma separated value, but it has missing values. It it considers them in terms of rows. Every single row is considered as a row, in data frame. The first one will be considered as features and label, and the rest are considered as data values, corresponding to those features. So you are reading that as you are feeding that as a string IO to the read CSV function. Okay, so that's the attribute. So now we could actually print it out, but it's going to give us an error. So we'll rectify that error. First, I want to show you this. So print df. The heck? Come on, yeah. So Unicode. Okay. CSV. Okay, I made this typo. DATA. Save and press F5. Okay, so if you're using Python 2.7, it's gonna ask you to convert this into Unicode. It has to be Unicode. If not, it's gonna accept it. But if you're using any other version of Python, you don't have to worry about it. It's gonna work perfectly fine for you guys. So let's go ahead and convert CSV data into Unicode before we feed that into uh, read CSV function as an argument. Copy, paste. So now it must be converted. So now save and press F5. Okay. Wait, this is the previous code error. You gotta wait for some time. I don't know why the heck it's taking this long. Did I press F5? Wait. Open it up. Close it. Okay. Here is the problem. Data. Save F5. Here you go. You got your pandas data frame now. So this is considered, the features and the label. You could. Yeah, there's nothing called feature and label. This is the column header over here, and this is your index. No, 0, 1, 2, 3 is your index, and the rest are your data. So now in our case we have two no data, and two data point that has no data. How do I say that? Yeah, this location has no data and this location has no data, so it's considered as NA. So how we want to fill it up? You want to like remove this one, like the entire column, or you want to remove the entire row where you have NA, or you want to like fill this up with a mean value, or like yeah, you have variety of options. You want to fill it with a mean value, or any other thing like in statistics range, or what else you have. You have variety of options to like patch this up to impute this. So that's what we're gonna like see. So now we created a data frame where we have missing data. So now let's go ahead and patch them up. You have different methods to do that. Which one is okay? So first, let's say in our case it's quite small. Our data frame is quite small. Let's say you have a data frame that has like hundreds of thousands of rows. It's too hard for you to like see how many NAs are over there. So you have the simple functions. I mean, df dot is null. So if it is null, it's going to take the summation of all the NAs in a single row, and then it's going to calculate for each and every single row. Okay, press F5. Okay, I've saved it. So here we go. This is our actual data frame. So you have one NA over there and then another NA over here. I'm not sure. Wait. Axis equals 1. Let's say whether it works. If it doesn't work, then let's not worry. Okay. Let's make it simple. I just want to give it a try. Okay, it's not working. Let's put it over there. Some just trying, so you could just ignore this one. Out of curiosity, I want to try this. Okay, now I want to change this to 1. Yeah, this is what I want. Wait, let me print this out twice. Print axis equals 0. So the first one is 1. Save, make it 0. Save that file and print it out. So this one, this line of code is calculating the summation of zeros, summation of node data NANs in each and every single row, and this one, in which the axis is 0, calculates NAN in each and every single column. So this is also something that you want to do. So let's say if your data is like column sensitive, then you want to know like how many NANs are in column C or column B or whatever. And if it's like, if you want to know in terms of row wise, in first row how many NANs are there, in second row how many NANs are there, in thousandth row how many NANs are there. So yeah, you could do that one by like using this piece of code over here, by changing the feeding axis as an argument to your function sum. Okay, cool. So next we now know the number of NANs in terms of rows, in terms of column. So now let's say we want to drop that up simply, drop if there's an NA, copy, paste. Let's do a simple thing by counting off. We don't want to see that. We now get pretty much clear about this 3 lines of code, what it is actually. And then you just clear this off out now. Then save and press F5. Here we go, it has dropped the rows with NANs, no data. I call it no data, okay? It's too hard for me to pronounce. So it's just dropped this row which has no data, and this row which has no data. So it just having a data that has all proper values, numerical values or whatever, categorical values or whatever. So this has done it for a row. So if you want to change it to a column, then you have to feed the axis argument. So let's try 0. I'm not sure which one is column and which one is row. You just play with it. I don't want to remember too hard things now. F5. I keep playing and I get to remember. So this one belongs to column. Actually 0 belongs to row, sorry. So if I make it 1, it belongs to. Yes, here we go. So now axis 1, it's taking as a column. So if there is any NaNs in a column, this column has an NaN, so it has dropped it. This has a NaN, no data, and it has dropped it. And A and B doesn't have A and B column doesn't have any NaN or no data, so it's accepted it. So this is your final data frame. So now you have a perfect data frame. So you could go ahead and do all your manipulations. Let's say you don't want to like lose this. You have this extra information and you are actually losing potential data that could add value to your classifier or your machine learning model or AI model or whatever model that you're building. So you want to just impute this, impute in the sense like insert some value over here which could be mean in terms of row or column or standard deviation or whatever. So let's see how we could do that. For that we have to bring in the impute. Yeah, this line of code is the one that brings a library inside for us. So let's go ahead and bring in the imputer. Okay, now we have the imputer inside. What's missing? Okay. So now we are going to call the imputer function on a variable of our choice. Okay, call it. So this is our variable. You could call that anything you want, but now we are like declaring the function with these things as a parameters. Axis, we get to know what there is, but in this case, the strategy is mean. So it's going to calculate the mean. So the missing value, it's going to consider all NaN as a missing value. Okay. You could actually check out the documentation of scikit-learn pre-processing imputer to check out what are the other strategies that are available to like patch up your missing data. So now we are borrowing the imputer. So now we have to like train the imputer so that it gets to know. It gets to know if it gets to calculate the mean or whatever that you want to calculate for the data set that are available. Okay, fit, it's going to train it and it's going to transform it. So actually fitting this data into this function and it's going to transform it for you. Fitting is going to calculate sort of mean based on the axis that you have specified here, whether it's row or column. So in this case, let's say it's A1 axis 1, which is row. So it's going to calculate mean in terms of row, and then it's going to patch up all the NaNs with that mean value. So that's what it's going to do. And then we just print it out. So let's see how it goes. We don't want to drop this. Don't drop it, bro. Let's comment it out. Print IMR. Save FR. Here we go. Here we go. What the heck is happening? What the heck is happening? So it's actually calculated the mean. So 3, 15, that's 7.5. It's 2. So let's go in terms of row. 5, 6, 11. So this is actually indexed. So you're going to ignore this one. So you're not going to consider that in calculating the mean. So 5, 6, 8, 11, 19, 19 by 3, which is actually 6.333. So it's done it based on the row. Now you go ahead and change the axis. So it's going to do it based on the column Fi and plus Fi. Save, Control X and then press Fi. So now you could see 3.0, 12.0, which is 15, 15 by 2, 7.5, and same is the case for this one. 4 plus 8, which is 12, plus 12 by 2, which is 6. So now we are successfully imputed your missing data. You should be pretty much proud of yourself. Now you have a proper data set. Even if now you have, let's say you have obtained the data from a real life situation, real time data, and then you found that there's some missing data in that one, and you successfully updated. You should be pretty much proud of yourself. Now you have a pretty good data set to do your machine learning. So let's say you have a categorical data, and how you're gonna like deal with them. We're gonna discuss that in our next tutorial. So thanks for watching this video. If you have any comments, comment below. If not, like and subscribe to the channel. Thanks for watching. Bye for now.